Okay, good afternoon, Year 12. Coming to you live from Wallington High School for Girls Library. So this is my attempt at Topic 5, Key Assessment 3. So let's have a look at this. The coffee husks shown in the photograph are a waste product of coffee plantations. Composting has been suggested as an environmentally friendly way of decomposing of these husks. All right. Decomposing, we know, is something that we talk about in topics 5 and 6, so that might come into this. The effect of adding cow dung to coffee husks before they are composted has been investigated. The table shows a percentage of organic carbon and nitrogen in the two compost heaps at the start and after 90 days. There's a table. Okay, comment. Now we know comments, this slightly dodgy one, but really what we want to do is make comments about the data, okay, on the effect of adding cow dung to composting coffee husks. Okay, so looking at what we've sort of highlighted here, we're talking about decomposition potentially. We want to talk about the start and the end of this process, and overall what the question is actually asking is what is the effect of this adding of cow dung to the composting of the coffee husks. So let's do the first bit. Okay, we've underlined the start, so we do need to say something about the start. Now if we look at the start, so i.e. after 0 days, we can see that if we compare the start of it with or without the cow dung, we can see that at the start the organic compound has got a higher percentage. So the organic carbon is a higher percentage in the husks alone. All right, and similarly at the start, the nitrogen has got the opposite thing going on. Okay, so the nitrogen has got a lower percentage in the husks alone. And that is significant because obviously what we're going to now do is let it decompose for 90 days and see what the effect is. Okay, so there's the first thing you want to say, because you do want to talk about the start of this process. Now let's then look at after, all right, 90 days. Now, if we take carbon, all right, as a thing, we need to start doing some maths here because we want to see how the carbon is affected over the 90 days. Now, here it goes from 54.5 to 41.7, which I believe is a change of 12.8%. And here we're going from 48.1 to 35.4, which is a 12.7 change. Really not very much if you look at that as a percentage. Okay, so you've quoted your figures, okay, and then you want to be saying something like the cow dung is not causing a change to the organic compound, the organic carbon compounds, okay, not a significant change at all. If we do the same thing with the nitrogen, all right, let's have a look. This is going to come out at 0.43%, and this is going to come out at 0.47%. Okay, so once again, a very slight or a no change to the increase in nitrogen. Okay, so we're saying carbon, no change, nitrogen, no change. So we've talked about the start, we've talked about the end, okay? We now need to talk about the effect, the overall effect. What's our conclusion, okay? And if this was our scientific experiment, if this is what we're looking at, okay, our overall conclusion would be is that adding cow dung has no significant effect on the composting or the decomposition of these coffee husks, okay? So overall, no effect using cow dung, okay, and obviously you can put that into slightly better wording than that. So that's the first question, okay. If you compare that to the mark scheme, you're looking at 1 for that, 2 for that, 3 for that, 4 for that, okay. Excellent. Now we go on to one of our favourites, a 6-mark question. All right. and a devise question. Now, you did one of these for Key Assessment 1, so you should be well practiced. Okay, so the changes in the compost heaps are due to the activity of decomposers and other organisms. Okay, devise an investigation to determine, there's a command word in there, the effect of the carbon to nitrogen ratio on the succession of these compost heaps. If we start with devise, okay, we know that we need to be talking about an IV, a DV, a CV, some repeats, okay, they're givens, and then sometimes we might want to be looking at a stats test. Okay, so we know as a bare minimum we need to be talking about those things. All right. If we look at succession, which is clearly something that you've studied in this topic, succession is really looking at the species diversity / change, and that is over time, isn't it? Okay. Now, outside, that time is going to be hundreds, if not thousands of years. In a compost heap, it's going to be far less than that. Okay, so this is something you're going to measure. Now, the other thing to think about with the devise question is we need to work out what CPACs we're looking at if we're going to talk about this. Okay, and we are looking at monitoring species diversity / species change. Okay, and therefore our CPAC, what we're going to look at is CPAC 10, all right, which is one that you haven't done yet, but you have taken part in that live lesson, which is all about sampling. Okay, so if we want to get to the top of the boxes here, we need to talk about that. So let's have a look here. Independent variable is the CN ratio. How are you going to do that? Okay, how many are you going to do? All right, so now effectively, all right, what you're going to have to do is have 5 compost heaps with measured different CN ratios. Okay, now how you measure that you don't necessarily know, but obviously it's doable with lots of different types of equipment, probes and things like that. But as long as you've got an idea that you're going to be measuring that, and then you want to start talking about your dependent variable. Now, in a very simple sense, you want to observe species diversity or the change in that. But really, again, dependent variables need to be measured, so it'd be better, okay, to be talking about some sort of measure. So that might be a count, okay, or a mass, or some way of measuring that number of species, okay. You need to be looking at identifying them and counting them, because clearly succession is about species diversity, so you need to have different species, okay. And you need to be talking about when you're going to do that as well. Now, we talked about succession being a time thing, so you're going to be measuring that over a period of time. Ideally, you're going to be saying what that time is. You might measure that daily, weekly, okay. I wouldn't go any longer than weekly probably for a compost heap, but you do need to mention what time period you're looking at here. And then we're on to our control variables. Now, a difficult one, okay, to actually control some of these things. But you certainly need to be monitoring them. And if you think about a compost heap, the things that's going to be changing with decomposition are things like water, okay, maybe CO2 availability, O2 availability. That's going to talk about humidity. If you ever put your hand in a compost heap, okay, the temperature is very high, because the more organisms you get, the more respiration you get, okay. And obviously the mass of that's going to change, because it will be getting less, because the organisms within that compost heap will be using that organic compound to respire, okay. And I'd say now here, if we've got this sort of thing in here, we're looking at around about 4 marks, okay. We've covered our basics, all right. We probably talk about repeats and creating a new mean, but we've kind of done an overall gauge of this experiment. But as we know, to get up into our 5 and 6 boxes, we need to talk about the experiment specifically, okay. Now, the first thing we're going to do that is the CPAC 10, and we need a sampling technique, okay. How are you going to measure species in a compost? Okay, you might use, if you're going to do the surface, you might use some quadrats or something like that. Although the best thing would probably be to be taking samples at different depths, so systematic sampling and working out the species in that respect. But systematic, even a random sample, but probably systematic here, if you're going with depths, in the different compost heaps, okay, is going to give you an idea of a sampling technique. All right. Now, once you've got that data through your sampling techniques, always put in that you're going to do a statistical test on it. Okay. Now, if you're doing the changes over time, all right, it's a difficult one. This you could be looking at Spearman's rank if you're doing it over time. But obviously, if you're comparing two different compost heaps, you might be looking at a t-test as well. All right. So actually, either one of those things, as long as you're clear how you're using it, would be fine. You don't really know much about those things yet, which is cool. We will be going through that in the next few weeks. But bear in mind that statistical things are going to do. And then the thing that we always leave out. Okay, you have got to actually determine the effect of carbon to nitrogen ratio on succession. So the final thing is how you're actually going to determine it. So you've done your method, you've got your results, you've done some statistical analysis on that. What are you going to do with that data to actually show it? Okay. So obviously the first thing you want to do is actually look at the species and sort of link it. So which ones are appearing at different CN ratios, okay? And then obviously you're going to look at the big thing with succession is numbers. So linking the number of species to the stage of succession and having an idea in this question and a clear understanding that succession should increase the species number over time. So if in one of the ratios you've got a larger number of species, it means that more succession has happened in that compost heap. Okay, again, okay, these devise questions, I think getting to this point, we can all do that in all of these devise questions. Okay, getting this bit, all right, is harder. I'm not saying you can't do it, but it's harder. And to do that, you've got to think about what CPAC am I using and what is the actual kind of answer we're looking for. Yeah, what am I going to do with all this data that I've collected to give me effectively a conclusion at the end of that experiment. I hope that's useful and I hope you're all well, and I look forward to seeing you again soon, and that's me done for now. Bye bye.